Good morning students. In this video we are going to see Unit 1 Laws of Motion Problems, page number 14 in your science book. 7th Roman, solve the given problems. Question number 1. Two bodies have a mass ratio of 3:4. The force applied on the bigger mass produces an acceleration of 12 ms minus 2. What could be the acceleration of the other body if the same force acts on it? The mass ratio of two bodies are given as 3:4 and then the force applied on a body is given as 12 ms minus 2. The acceleration of a body is 12 ms minus 2. We have to find out the acceleration for the other body if the same force acts on it. If 5 Newton force acts on a body m1 and the same 5 Newton force acts on the body m2 also, then what is the acceleration of the smaller body? So the ratio of mass of two bodies 3:4, acceleration of bigger mass 12 ms minus 2. We have to find out the acceleration of the smaller mass. So the formula F is equal to ma. Formula to find out the acceleration is F is equal to ma. So we have to find out the solution for this problem. m1 is to m2 is equal to 3:4. a1 is to a2 is a1 is to 12. That is a1 we are going to find out. So a1 is to 12. Now according to Newton's second law, F1 is equal to m1 a1. What is m1? 3 kg. a1 we are going to find, and then F2 is equal to m2 a2. What is the value for m2? 4 kg, and a2 is 12 ms minus 2. So 4 into 12, 48 kilogram ms minus 2. Now the condition given in your question is same force acts on the two bodies. That is, the force acting on m1 and m2 are same. So F1 is equal to F2. Now what is F1? 3 into a1 kg is equal to 48 kilogram ms minus 2. Substitute the value for F1 and F2. From this we have to find out a1. So a1 is equal to 48 kilogram ms minus 2 by 3 kg. Now in this kg and kg get cancelled. So the remaining term is 48 by 3. Now we have to divide 48 and 3, we get 16 ms minus 2. So in the result we have to write acceleration of the other body is 16 ms minus 2. Question number 2. A ball of mass 1 kg moving with a speed of 10 ms minus 1. The mass of a ball is given as 1 kg and then this ball moving with the speed as 10 ms minus 1. It rebounds after a perfect elastic collision with the floor. So it rebounds when it reaches the floor. It reaches the floor and again it rebounds. So we have to find out the linear momentum of the ball. What is linear momentum? The product of mass and velocity. So given data, mass of an object gives 1 kg and initial speed gives us 10 ms minus 1 and final speed minus 10 ms minus 1. Initial speed the ball reached the ground and final speed it rebound. So we have to write it as minus 10 ms minus 1. Here the minus indicates because it rebounds elastically. So we have to find out change in linear momentum. So the formula to find out change in linear momentum is mv minus mu. This is delta p. So delta p gives us mv minus mu. So the solution for this problem is change in linear momentum. Delta p is equal to mv minus mu. So the mass is given as 1 kg. Final velocity is minus 10 ms minus 1 minus, and then mass is given as 1 kg and initial velocity is 10 ms minus 1. So 1 into 10 minus 10 kilogram ms minus 1, and this minus is the formula minus. So 10 kilogram ms minus 1. We know that minus and minus plus. So we have to add 10 and 10, we get 20. So we have to write the sign minus. So minus 20 kilogram ms minus 1. So what is change in linear momentum of an object? It is minus 20 kilogram ms minus 1. Now question number 3. A mechanic unscrews a nut by applying a force of 140 Newton with a spanner of length 40 centimeter. A mechanic unscrews a nut by applying a force of 140 Newton with a spanner of length 40 centimeter. That is, the length of the spanner is given as 40 centimeter. By using the force as 140 Newton, he is unscrewing a nut. Now, what should be the length of the spanner? We have to find out the length of the spanner. Suppose if a mechanic use a force as 40 Newton. The mechanic use a force as 140 Newton. So, the length of the spanner is given as 40 centimeter. If a mechanic applies a force as 40 Newton, we have to find out the length of the spanner. Given data, force applied to unscrew nut F1 is equal to 140 Newton and then the length of the spanner is 40 centimeter. So, we have to convert this centimeter into meter. That is, the formula is, that is the unit for the length of the spanner is meter. We have to convert this. So, 40 by 100 it gives us 0.4 meter. So, the force applied to unscrew a nut is 40 Newton. We have to find out the length of the spanner. So, the formula to find out the length of the spanner is moment of force is equal to force into distance. So, the solution, equating moment of force on both cases, that is F1 d1 is equal to F2 d2. F1, what is the first force? 140 Newton and then the length of the spanner is 0.4 meter and then the second force is 40 Newton and d2, that is the length of the spanner for 40 Newton we have to find out. So, d2 is equal to 140 into 0.4 by 40 Newton. Here Newton and Newton get cancelled. So, 14 into 0.4 by 4 meter, that is here we have 0 and denominator also 0. So, 0 and 0 get cancelled. Now, you have to divide 4 and 0.4, we get 0.1, that is 14 into 0.1 meter, we get 1.4 meter. So, the length of the spanner is 1.4 meter. Question number 4. The ratio of masses of two planets is 2:3. Here we have two planets, it having the masses 2:3. The ratio of the radii is 4:7. The radius of this planet is 4:7. We have to find out the ratio of acceleration due to gravity. That is, we have to find out small g value for these two planets. We have to find it in a ratio. So, the given data, ratio of masses of two planets 2:3 and then the radii is 4:7. We have to find out ratio of acceleration due to gravity. So, the formula to find out acceleration due to gravity, g is equal to gm by r squared. Small g gives us acceleration due to gravity, capital G universal gravitational constant and then capital M mass of the earth and r is the radius of the earth. So, acceleration due to gravity for first planet g1 is equal to gm1 by r1 squared and acceleration due to gravity for second planet g2 is equal to gm2 by r2 squared. So, ratio of acceleration due to gravity g1 by g2 is equal to gm1 by r1 squared by gm2 by r2 squared. So, gm1 by r1 squared into r2 squared by gm2. Here capital G and capital G get cancelled. So, the remaining term is m1 by m2 into r2 squared by r1 squared. Now, here we have to take as a whole square, that is r2 by r1 whole square. And then mass of the planet m1 is 2 and mass of the second planet 3 and then radius of the second planet 7 and radius of the first planet 4. So, 2 by 3 into 7 by 4 into 7 by 4. Now, we have to cancel 2 and 4. So, we get 1 by 3 into 7 by 2 into 7 by 4. Now, we have to multiply all the terms. So, 7 sevens are 49 by 24. So, we have to write it in ratio. Our question is to find out the ratio of acceleration due to gravity. So, the ratio of acceleration due to gravity is 49:24. So, the ratio of acceleration due to gravity 49:24. Thank you, students.